So if we're drawing Lewis dot models, just let's roll through like aluminum here, for example. Now let's not go aluminum, let's go iodine. So iodine, the first thing to do would be find out how many electrons iodine's going to have. Because to draw a Lewis dot model, we're just going to draw the valence electrons that are around it. So we need to first find out that. So we're going to look at a periodic table for iodine. It's the capital letter I. We're going to find out on the right side.
7.
Yeah, iodine's going to have 7 valence electrons, exactly. So iodine's going to have 7 valence electrons. So to draw a Lewis dot model, we need to draw its chemical symbol, a big capital I, and then you put a dot representing an electron around on each side of the I. Where is it? Like that. So there's 4. Now you got to draw 3 more. So 3 of those are going to get paired up.
Doesn't matter which ones.
I don't think so, no. Generally, you kind of pair up the sides and then you fill in the top. So I would do the 2 sides and then the top and leave the bottom blank. So there's a Lewis dot model for iodine.
Okay.
And then, like I said earlier, for the CH2, first you do a Bohr model for carbon. There's a Bohr model for carbon, which shows you have 4 valence electrons. This is just for the screen recording. 4 valence electrons. So you're going to draw your carbon with 4 dots around it. Then it's bonded to hydrogen in CH2. Hydrogen only has 1 proton and 1 electron. You can find that on a periodic table. Hydrogen's atomic number is 1. So it has 1 proton, 1 electron. So you draw each of them with 1. And I drew them on the insides toward carbon. Then draw a line showing that they're bonded. So this is CH2, the Lewis dot model. And here would be the Lewis dot model for hydrogen, or for water, H2O. All right. So you said SO4. So looking at the bottom one there, we're looking at SO4. So first you got to draw a Bohr model of what?
A Bohr model of what?
To do SO4, you have to draw a Bohr model of which element first?
Sulfur and oxygen?
Right, exactly. And we already have a Bohr model of oxygen from H2O, so we know oxygen's going to have 6. It's going to have 2 in the first energy level, and then 6 in the second energy level, so we just draw the 6 valence electrons, those 6 dots. 2 on top, 2 below, and 1 to each side. And now we got to do sulfur. So you look at the periodic table, and sulfur's atomic number is 16. So I'm going to draw a Bohr model for sulfur, atomic number 16. So I start off S, 3 energy levels. Just going to start with 3 rings. Now I have to place 16 electrons. 2 go in the first energy level. How many go in the second energy level?
8, right?
8, exactly. A maximum of 8.
And then you fill the rest.
Exactly. Here's the next 8, giving us a total of 10 electrons in sulfur. And then now we got to fill in 6 more for sulfur. So there's your Bohr model of sulfur. So the key to doing Lewis dot models, the key to now doing a Lewis dot model is to look at what?
I'd place 6 valence electrons around.
Exactly, exactly. So we see there's 6 electrons in the outer shell, so we place 6 valence electrons around the chemical symbol S. And yeah, so I'd start with 1 on the top, 1 to the left, 1 to the right, 1 on the bottom, and then we have to draw 6 valence electrons. So now I'm going to put 2 more. You can do them on top and bottom. You can do them on both sides. I'm going to do them on both sides because I know those are going to bond with the oxygen. So I'm going to start with S, looking like that. Oxygen also happens